question 3. This is quite a big question. It's a question on equations of motion, so in other words, constant acceleration. It's all to do with projectiles, and it's got a couple of stings in the tail. They can be overcome, but you've just got to work very carefully with these things, and you've got to understand the situation. So let's have a look first at the question here. The ball A is projected vertically upwards at a velocity of 16 meters per second from the ground. Ignore the effects of air resistance. Use the ground as a zero reference. All right, so we've got a ball A projected upwards, and I'm going to go say upwards is positive. This is a very important step because all of these things revolve around something going up and coming down. And if going up is positive, then coming down is negative, and you've got to take that into account wherever you've got a vector quantity. So if you're working with vectors, you've got to know what is minus and what is plus, what is the positive direction, what's negative. So there is ball A, and it goes upwards. As I've decided on my convention now, it is plus 16 meters per second is its initial velocity. We say the ground is the zero reference point. We're now asked to find the time taken by the ball to return to the ground. So in other words, it starts up there, going upwards, plus 16, it goes doop, 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 up to the top, and then it falls down again. Now what I'm going to do is there are various equations you could use. You could use Vf is equal to Vi plus A delta t, and remember that this A is going to be a G. And you could also use this equation, delta y is equal to Vi delta t plus half A delta t squared. This one takes, takes a little bit of physics for this one, but this is definitely my simplest equation. Because you see, there some information that I know, which I wasn't given directly, is that when we get to the top here, if we take this as Vi and this as Vf there is 0. And then I believe it is permissible to say that if the velocity, the initial velocity is plus 16 meters per second, we can assume the symmetry of this thing, and then when it gets back down there, it's going at minus 16 meters per second. So let's use this equation and see how far it gets us. So we're taking upwards as positive. We say Vf is equal to Vi plus A delta t. Now I'm going to put in all the values that I know. I've got Vi. Vf is going to be equal to 0. And Vi is going to be plus 16. The acceleration, now just remember that is a vector. Positive I've taken as positive upwards. And therefore the acceleration is going to be minus 9,8 times delta t. Okay? So therefore, I can say that delta t is going to be minus 16 over minus 9,8. And that is the time taken to go from ground, the 0, up to the top. And when I come down again, all right, there I get an answer which is going to be equal to 1,63, I think, 1,63 seconds. And then when it's coming down, I'm going to change my equation. Vf is equal to Vi plus, or I'm not going to rewrite this. I'm going to take my final velocity when it's coming down. It's going to be minus 16. Vi, the initial velocity at the top now for the downward trip, is going to be 0 plus, it's still minus 9,8 over delta t. And so therefore delta t is going to be for, this is for up and this is for down. Delta t is going to be minus 16 over minus 9,8. Same answer, 1,63. Therefore, delta t, we'll call this the total time, is going to be 1,63 times 2, which is 3,26 seconds. But you know, something here, something that I can do here, I could go, this is taking the up trip, and this is taking the down trip. But you know what I can do is I can do the up and down all in one, because what I know is that the initial velocity is going to be upwards plus 16. The bottom is going to be, it's going to be minus 16. And in fact, we know that this symmetry exists because here it's all kinetic energy. Here it's all kinetic energy as well. So in other words, although we're converting kinetic into potential, when we come back down, we've got all of that energy back at kinetic energy again. So from that fact, I know that my velocities must be the same. But what I could also do is I could say Vf is equal to Vi plus A delta t. Now watch. The final velocity is going to be minus 16 there. The initial velocity is going to be plus 16 there. And this is going to be minus 9,8 times delta t. So what I would get here is delta t is equal to minus 16 minus 16, so I've taken that to the other side, divided by minus 9,8, and there I'm going to get 3,26 or 27 would also be acceptable, 27 when you correct that. Okay, and there the answers as given. If I use this delta y, I could do it all in one step as well, and I'm not going to do it, but remember that that is displacement. If we start here and we end here, then the displacement will be equal to 0. I know what my initial velocity is, I know what A is, and then I've got to work out, I've got to do a quadratic equation. No, I won't have to, because that's going to be 0, so that delta t will come to one side, and the delta t's will cancel once. I'll get rid of the delta t there, and I'll be left with just delta t over here. So I can use that equation as well.